Service calls are expensive in the modular industry because usually it involves having somebody get in a car or a plane and drive out to a remote site, to fix a problem that shouldn't have existed in the first place. Hot and cold calls are an example. So how do you design a building so that you don't have hot and cold calls? Short answer, you can't avoid them altogether, but you can reduce the risk of them. One way that we're not going to talk about today, there will be another video on this, is to zone correctly. In other words, group the right types of spaces together. You can't always do that on small buildings. Not only that, when a building leaves the plant, you don't necessarily know which side is going to be west facing or north facing, or they might put it in a different orientation on the plan than you'd expected. But one of the big things that you can do to avoid hot and cold calls, or at least avoid the cost, a high cost associated with hot and cold calls, is to install dampers. So on the screen right now, I did a quick Google search for takeoff collar with damper. And my recommendation would be anytime you install a supply air takeoff collar, that you get one that has a damper integral to it. When I've looked into this in the past, the cost of adding a damper is maybe $1 or $2. And so even for an entire building, if you had 10 diffusers, you're looking at an extra $10 or $20. And there is no additional labor cost. You still have to put the damper in, you still have to hook up the flex duct or the duct. There really is no incremental cost. So you ought to have dampers in your takeoff collars pretty much every time on the supply. The advantage of having a takeoff collar is if somebody's complaining that they're too cold or they're complaining that they're too hot, you can make adjustments. Now, it doesn't have to be a takeoff collar. Some people prefer to have an adjustable face diffuser. I guess those work as well. And if you've got a hard ceiling as opposed to a lay-in, then those probably make more sense. What you're trying to avoid is having one damper downstream from another. So for example, if you have a 10-inch takeoff that subsequently splits into two 6s or a 6 and an 8 or whatever, you would want to have the damper in the 6 and the 8. You do not want one in the 10. You don't want one in the main. You don't ever want to have two dampers in series. That just leads to unstable conditions. The second thing is you want to make sure that the ducts are sized right to begin with. This isn't always done well. Okay, so here's the sample building, and I've made it anonymous by removing the name, etc. You have a lot of different types of rooms. You've got a conference room, you've got offices, a lobby, reception, restrooms. The offices have windows, the other side of the building doesn't. Each of these different types of rooms is going to have a different load. You really do want to avoid guessing as to how much air needs to go into each space. Not to oversimplify it, but here's what's going on. On your worst case day in the summer, you've got heat coming in through the windows, you've got heat coming in through the roof, the walls, people, lights, equipment, etc. And a load calculation calculates how much heat is being given off into the space. And then, knowing the temperature of the air coming in, you calculate how much of that air it takes to neutralize all of the heat. To run load calculations, it doesn't take very long, and here's an example output sheet, and it tells me what the sensible load is for each room in the building. And I've got an online calculator created here where you tell it what size of what tonnage your unit you're going to put in, and then what number of diffusers you're going to have, and this, to distribute it, and it tells you what size it's going to be, as well as what size the trunk needs to be, etc. One of the ways to run up the cost is to have your branch duct be the wrong size. That goes from being a quick damper adjustment to needing to send a guy out there, get up above the ceiling. You have to tap a new branch off, you need to run a new duct, you need to install a new diffuser. If you can avoid putting in the wrong size equipment up front, it saves you so much trouble. What's the added cost of actually having somebody calculate the loads for you? takes me about a half an hour, or if you've got your own engineer, it really does not take long to calculate the loads. And you compare that to the cost of driving a guy out to the site to fix the issue. Once again, you can't guarantee that you're going to avoid the issue. They may put more equipment in a room than you were expecting, but by going off of the best information that you've got in a building that's zoned correctly, and if you put dampers in the supply, you're able to avoid most hot and cold calls, and you're able to fix most of them using dampers instead of something much more expensive. I've included a link to that calculator tool, the duct sizing tool, in the notes down at the bottom, or if you're seeing this on the web page, I've got a link there as well. Let me know if this is helpful or if you have any questions on it, and I will talk to you later. Thank you.